So we've got now two different problems. We have an f of x and a g of x. My son was writing on it. Now, what happens if, y'all stay with me, this is the new part.
Yes.
If I say, but I want to know what f of x plus g of x is. Oh, what would I do?
You add them.
10 and 27.
Hold on. 10 and 27. No.
I see what it. You
One
get
and
the
nine.
answers from the f of x, and then you get the answers from the g of x, and then you graph it.
Okay, so you could do that, yes. So to start off with, what do we know f of x as?
We know it has,
I'm not talking about evaluating it yet. I'm just saying, what is f of x? It's 3x minus 2, right? We know that. We know that this is the same as this, yeah? But, what would g of x be?
2x plus 7.
2x plus 7. So here we have two different names for the same thing, right? So if we're saying we want to add f of x and add g of x, it's like saying I want to add 3x minus 2 plus 2x plus 7. Okay? So to find your equation of f of x plus g of x, this is what you're looking at right here. This is equal to this. Okay? So then, when I look at this, I'm like, ew, that's messy. So what could I do to clean it up?
Simplify.
I could simplify it. How would you start me off with simplifying it? There you go, combine like terms. So I could say 3x plus 2x, and that would be 5x. And then I could say negative 2 and positive 7. 5, that's right. Positive or negative 5? Positive 5. So, f of x plus g of x is equal to 5x plus 5. Alright?
That's how you do it.
That's how you do it. Now, you could evaluate this.
Excuse me.
You could evaluate this and say, x and then f plus g of x. Okay, you could say it like that and say you wanted your numbers to be 1, 3, 5, and 10. So evaluate this, f of x plus g of x, at 1. What would it be? 5 times 1 plus 5. That's right. 10. Yes, sorry. 10. What about 3? 15, 20. Yes, very good. Jonathan, what about at 5? Evaluate this at 5.
That would be 30.
Yes, 30. Oh, trend going. Tyler, what would it be at 10?
Oh, wait. 40.
55.
Yep, 55's in there.
Your trend is broken. That's
Wait.
okay.
10 times.
Well,
wait,
not
you
really
got five
broken.
more?
Huh? If you had 7, it would be at 40, right? Yeah.
What do we times in 10
10 by 5
Oh.
plus 5.
Oh,
So, what's interesting about this, y'all bear with me. What's interesting about this, we looked at x as 1, right? Well, look at here. X is 1, x is 1. What did we do with those y results? We added them. Does that stand true for all of them? Let's see. 7 plus 13. Yup. 20. Yup. 10. What about 13 and 17? Yeah, that hits 30. What about 28 and 27? Yup, that hits 55. So, there's two ways that you can do this. And that is, first of all, you can actually add the equations together to get a new equation and then evaluate it. Or you can add the parts together to evaluate it. Okay? So either would work. They will come up with the same answers. Any questions so far? How are you doing? Okay. All right. Next. So now, what if we're looking at these same old problems, but we're told, hey, I want to subtract them.
See, I know how to do that.
Okay, tell me how.
I know what you do.
Yeah?
Never mind, I forgot.
Okay. Alright, so if I'm looking at f of x minus g of x, what's my other way to say f of x?
3x.
There you go, 3x minus 2. What's my other way to say g of x?
2x plus.
And what's my function between them? Subtract. Now, something interesting happens when you go to subtract. Because there are multiple terms here, this subtraction symbol actually distributes. So it goes to the 2x and to the 7x. So you will see it as 3x minus 2 minus 2x minus 7. See how that subtraction symbol made these two negative? They were positive, now they're negative. Alright, so now how can I simplify this? Combining like terms. So my like terms are?
3x and 2x.
Right, 3x and negative 2x.
Negative.
Which would get me
Negative 1x. Positive.
positive 1x. Which I'm just going to put as x. Because that's the same thing. And my other two like terms, negative 2 and negative 7. Negative 9, yes. Alright. So, my equation I'm looking here is x minus 9. That is f of x minus g of x is equal to x minus 9. With me? Alright, so let's evaluate.
Huh? No. How'd you get 9?
Negative 2 plus negative 7.
How'd you? Wait, I thought.
Subtract.
Did you change the problem?
Yeah, it's a negative.
Yeah, it's negative.
Oh, yeah, the negative distributed. So now this is negative 2 and negative 7.
I thought it was 5x plus 5.
Yeah, now I'm subtracting. It was adding earlier. Alright, so we got x and we got f minus g of x. Okay. So let's do those same numbers. 1, 3, 5, 10. Tell me about 1. -8. Tell me about 3. Yeah, -6. -8, -6, 5. -4. And 10. 1. Alright. Now, does it still hold true that you can say 1 minus 9? Yes.
No.
Does it still hold true that you can say 7 minus 13? Yep. 13 minus 17? Yep. 28 minus 27? Yep. Alright, everyone see that? Good with it?
Yes. I see
Nope.
it for one.
Alright. Trying to think if I
I wish I
forgot.
can get something to drink from the vending machine. Hang up the water.
You're not supposed to eat and drink in class anyway. You gotta wait till middle, till switch.
You can drink in here.
You can drink water.
I mean, it's baby water.
That's what I told my mom with coffee.
There's a way to turn it back.
Because everyone was like,
They gotta
doesn't
make
only
you
drink
better
water in
back.
class.
It's made with water. Tank.
Miss Starling, you're not drinking water. You gotta drink.
I'm a teacher.
Yeah.
I'm a
Rules are
teacher.
different.
Teachers go to the state.
I teach these boys about the punishment and repercussion of disrespecting people. I'm a teacher, so I can drink
Here's what I'm starting. I mean, like, I gotta urinate so bad, but I want to do my fast. Like,
I mean, that's up to you.
and she tweaking
If
it.
that's that decision you want to make it.
can I go without using this, like, for the first time? Like, what's
So,
up?
alright,
She tweaking it.
I have a fever.
let's say,
She tweaking bad.
let's say P of X and nothing. And M of X. Let's do
That baby is strong. You better leave her alone. You better leave her alone. That baby is strong.
Alright, so we're gonna talk about something brand new today. Okay. What do you notice different about this than ever before?
There's numbers above the
Yeah, it's not no yeah.
There's numbers bigger than X. There's X squared. That's what we call that.
I knew it.
X squared.
I don't like it.
That's times 4, right?
No. It's X times itself. X times X. Alright, yeah. So exponent is like X times itself. So think about 3 squared. 3 squared is equal to 3 times 3. What about 9 cubed?
9.
There you go. 9 times 9 times 9. So therefore, if we follow this logic, X squared is what? X times X. Exactly. Very good. Okay, so keep that in mind. Now, we're looking at X squared. And what if we're told that what we need to do is say P plus M of X is what we need to find. How do I find that?
We solve.
I wouldn't solve the equations, but I could just say this plus this, right? The red plus the red. So I could say 2x squared minus 4x plus 2 plus 3x squared plus 2x minus 6, yeah?
Yeah.
Okay. Now, combining like terms with exponents is kind of interesting, okay? Because you can't just say, oh, x squared plus x, that's 2x squared. No. This is your term. So if you have 3x squared and you have 4x squared, you don't just add them together to make 7x squared. No. What you have is 3x squared plus 4x. Your x squared can only go with other x squareds. Okay? With me? Okay. So what that means for this in brown over here, what would be my like terms? 2x squared and what?
3x squared.
And 3x squared. If I added them together, what would it equal? 5x squared. What are my other like terms?
Negative 4x and 2x.
There you go. Negative 4x plus 2x. What would that equal out?
Negative 2x.
Negative 2x.
Listen, I don't know you. I gotta pee. I'm sorry.
Alright. And the last ones would be 2 and negative 6, which would equal what? Negative 4.
But stop that.
Alright, negative 4. So now you could technically evaluate it. You could say x is p plus m of x, and then say x is 1, 2, 0, and negative 1 on that side. Okay? So, talk to me about this expression at 1, or at x is 1. Well, first, we put 1 there. What is 1 squared? 1 times 1.
Oh, sure.
Yeah. So 5 times 1 times 1 would be what?
5 times 1, 5.
5. And then I got 2 times what? Negative 2 times what?
Times
1.
It'd be negative 1.
Negative 2. And then I have negative 4. So order of operations tells us that since these are both adding or subtracting, we just go from left to right. So 5 minus 2, 3. 3 minus 4, negative 1. So this is negative 1. Now let's do it at 2. Okay. We got 5 times 2 squared minus 2 times 2 minus 4. Okay? Talk me through it. What's 2 squared?
2 squares. What?
It's 2 times 2 times. So it's 4.
I said that.
You did. Good. Alright, 5 times 4?
20.
20. 20 minus what?
4.
4 minus 4. So 20 minus 4? 16. 16 minus 4? 12. So of p plus m of x at x is 2 equals 12, right? Okay, let's try it at 0. What would you get if 0 was squared? 0. Yes. You'd say 5 times 0 squared minus 2 times 0 minus 4. So this would be 0. This would be 0. This would be negative 4. Alright, so we got 0 plus 0 minus 4 is negative 4. Alright, and lastly, we got negative 1. Oh, now let's think about this. If you are looking at negative 1 squared, that's saying the same as negative 1 times negative 1. So what's your result for negative 1 squared?
Negative 1.
Positive 1.
Positive 1. So that would be positive 1.
Oh, word.
Alright, so tell me what my equation is when I have negative 1 as x. 5. Okay. Alright, very good. So we said negative 1 squared is negative 1 squared. We're saying negative 1 squared is negative 1 times negative 1. A negative times negative is a positive, so therefore it's positive 1.
Oh, I said that.
Alright, so 1 times 5 is what? 5. And then what about this one? Negative 2 times negative 1.
Positive 2.
Positive 2. And negative 4 just stays negative 4. So let's see. 5 plus 2 is 7. Let's pretend that's a 7. Alright, 7 minus 4. It is. We're pretending. Alright, yes, 3. So, p plus m of x evaluated at x is negative 1 equals 3. Thank you. Alright, y'all with it so far? Tyler, you awake? You alive?
Working at the hospital.
Most interesting thing ever.
You won't pass algebra looking at the hospital.
I'm learning about history.
I'm working on my eyelids though.
Learning science.
Okay. So there's one little weensy other thing I want to talk about today. Okay? It's kind of cool.
Wait, I have a mission for you, please. Come speak easily.
Put those on my desk.
I ain't stupid.
Put them on my desk.
I ain't get you for your desk.
I don't care. Put them on my desk. Don't be playing with them. You 5? I said put them on my desk.
Oh, that's why I got them right now.
I know, and I said put them on my desk. Cause the one's here.
Okay.
Don't need it.
You trying to get electrocuted. I will let you do it.